In this lecture, I want to discuss the operating characteristics of windmills, site selection, and the environmental issues to driven the project, and the economic aspects of the wind energy. Now come to the operating characteristics of the windmills. All wind machines share the certain operating characteristics such as the cut-in, rated and cut-out wind speeds. For example, a 10 kilowatt wind turbine may not generate the 10 kilowatts until the wind speeds reach the 40 kilometer per hour. The rated speed for most machines is in the range of the 40 to 55 kilometer per hour. The cut-in speed is the minimum wind speed at which the blades will turn and generate the usable power. This wind speed is typically between the 10 and the 16 kilometer per hour. The rated speed is the maximum wind speed at which the wind turbine will generate its designated rated power. At wind speeds between the cut-in and rated, the power output from a wind turbine increases as the wind increases. The output of most the machines levels up above the rated speed. Most manufacturers provides the graphs called the power curves showing how their wind turbine outputs varies with the wind speed. Now the cutout speed. At very high wind speeds, typically between 72 and 128 km per hour, most wind turbines ceases the power generation and shut down. The wind speed at which shutdown occurs is called the cutout speed. Having a cutout speed is a safety feature which protects the wind turbine from the damage. Shutdown may occur in one of several ways. In some machines, an automatic brake is activated by a wind speed sensor. Some machines twist or pitch the blades to spill the winds. Still others use the spoilers, drag flaps mounted on the blades, or the hub, which are automatically activated by the high rotor RPMs, or mechanically activated by a spring-loaded device which turns the machine sideways to the wind stream. Normal wind turbine operation usually resumes when the wind drops back to a safe level. Now the Bates limit. It is the flow of air over the blades and through the rotor area that makes a wind turbine function. The wind turbine extracts the energy by slowing the wind down. The theoretical maximum amount of energy in the wind that can be collected by a wind turbine's rotor is approximately 59%. This value is known as the Bates limit. If the blades were 100% efficient, a wind turbine would not work because the air, having given up all its energy, would entirely stop. In practice, the collection efficiency of a rotor is not as high as 59%. A more typical efficiency is 35 to 45%. A complete wind energy system, including the rotor, the transmission, generator, storage, and the other devices, which all have the less than perfect efficiencies, will deliver between 10% and 30% of the original energy available in the wind. The site selection and the environmental issue to design the wind energy energy sources. The prospective developers of the wind energy projects will normally be able to refer to wind the surveys in most of the developed countries in order to make a preliminary identification of sites suitable for the wind farms. Wind energy associations exist in the UK, Europe and the USA, and the European Union also holds the Europe-wide figures. In other parts of the world, the wind data that is available may be less precise, though many countries are now taking the greater interest in the wind resources. Once a potential site has been identified, it must be studied in more detail to confirm that it is suitable or not. Long and short-term wind speed measurements will normally be needed to ascertain the wind regime. Only when these figures are available can the economics of the project be determined with an accuracy. The figures of at least one full year will normally be required longer if possible. Offshore projects require the same attention as the onshore schemes, but offshore wind data is less likely to be available. It is possible to gain an estimate of the wind regime in an offshore area from the satellite images also. This can provide an indication of sea roughness from which the wind speed can be calculated. As with an onshore site, the accurate measurements over at least a year will then be needed to confirm the local wind regime. The site development could also damage the fragile environment such as peat bogs. This should be avoidable if good construction practice is followed. The major objections to onshore wind farms are eliminated with the well-chosen offshore sites. These can be 15 km or more offshore, making them all but invisible. Beyond the 45 km, the curvature of the earth should render a wind farm completely invisible from the ground level. The more local environmental impacts of the wind power may be summarized as follows. Wind power is also a clean source of energy. Its use does not lead to significant environmental or atmospheric emissions. The more local environmental impacts of the wind power may be summarized as the carbon dioxide emission. The table contains the estimates for the lifetime carbon dioxide emissions from a wind plant and from a coal and a gas-fired power station. The lifetime assessment looks at the emissions that take place during the manufacture of the components of a power plant, as well as the emissions that take place during the whole of its operational service. As a result of the former, a wind plant releases 7 tons of carbon dioxide for each gigawatt hour of power it generates. As a table shows that a coal plant releases well over 100 times more, and a gas plant close to 70 times the amount from the wind plant. Other pollutant emissions, aside from the carbon dioxide, the wind power produces less sulfur dioxide, less nitrogen dioxide, and less of the other atmospheric pollutants that are emitted by the coal-fired power plants and to a lesser extent by the gas-fired plants. However, the wind power plants are not entirely benign. The use of wind power does have negative consequences for the environment. Second point is the visual impact. The turbines have to be in open land or at sea so that they are clearly visible in the direct sight. Note that the larger the diameter, the slower and more graceful the rotation, and the higher the tower and blade. The visual impact is the very much important parameters. The turbine color can be chosen as the most acceptable, which is usually white for the viewer. Nearby obstruction by hills, buildings and trees etc. can prevent the sighting. Turbines may be considered the detrimental if observable from the historic sites or in the areas of the scenic beauty. The simulation software is used to give a dynamic visual impression of the wind farm from all viewpoints before permission is granted to construct. The wind farms cover a large area and they are impossible to hide. So while the actual land utilization is low and the area occupied by a wind farm can be used for other purpose too, the site of an array of wind turbines open in otherwise undeveloped rural areas is considered by many to be visually offensive. The weight placed on the visual impact of a wind power development will vary from site to site and from community to community. This is a matter of taste and it is virtually impossible to quantify. Nevertheless, it will restrict the available sites for wind power development. The most important parameters is the sound and noise. The noise, a low frequency hearing, has been compared to the sound of wind in the branches of a tree, but the constant frequency is likely to make it more intrusive than the sound of the wind. To this rotor noise must be added the mechanical noise emanating from the gearbox and the generator and occasionally some electrical noise. The blade noise is the most serious of these. Turbine noise is generally more intrusive when wind speeds are low, but it will be masked by background noise provided the machine is far enough away from the human habitation. This again will limit the possible sites of the wind development. Audible noise from machinery, blade tips, tower passing, etc. is expected to be less than 40 decibel dBA at 250 meter, which is sleepable. Infrasound from vibrations not audible or open detected but contentious. Such impacts are not detectable from the offshore wind farms. Modern machines are considerably quieter than the early developments as manufacturers seek to respond to public comment and to improve the efficiency. Noise is often a sign of less efficient energy capture. TV and the microwave. Under the certain circumstances, wind turbines can also cause the electromagnetic interference affecting the television reception or the microwave transmission. So avoid the line of sight with the local transmitters. Next, come to the ecological impact is very important. The ecological impact of the wind power normally centers on its effect on bird populations. The most obvious danger of birds being injured or killed when the flying through the rotor blades appears on current evidence to offer only a small threat. This could be considered more serious if a colony of an endangered species lived in the vicinity of a proposed wind farm, but birds do seem to learn to take account of the wind farms. Generally, very seldom less than the house window. Avoid the sitting near the hedges or other insect feeding areas. Species vary considerably in their behavior and so expert investigation is needed before permitting the construction of the wind turbine. Very important parameters is agriculture. Horses and the cattle may be alarmed at first but will become accustomed to the noise. In general, the previous use of the site for animals and crops continues unaffected apart from 1 to 2% of the area used by the tower bases, substations and unsurfaced roads. The radar, another important parameters for the radar disturbance. The ground-based radar is affected, but the airborne radar should not be. So more modern radar systems are generally less subject to the interference. Possible interference for flight operators who can use the special erasing softwares for their screens. The sunshine shadows may give the flicker through the windows. Turbines can be automatically shut down if such flicker is likely. Grid limitations for the exportable power may require the grid upgrading. Benefits to the local community also, it is as a whole may be offered by the developers such as the cheaper electricity supplies, donations to the schools, etc. Now come to the economic aspects of the wind energy. The economic analysis of the renewable energy systems mainly focuses on the ability of the system to pay back the initial investment and the operation costs within a reasonable period of time. The lifetime cost of the wind energy system can be split into the initial cost for system manufacturing and installation, operating and maintenance cost, decommission cost. The initial upfront cost of the wind energy system is usually the highest, more than 75%, and typically includes the turbine, including rotor, tower, and the drivetrain, foundation of the windmill, land rent, electrical equipment cost, connection to the grid, road construction cost, and other infrastructure, transportation, installation labor and expertise, and the associated soft costs. Operating and maintenance costs are relatively low, especially that there is no fuel cost is involved here. The breakdown of the wind energy system cost is like that. That is, the turbine itself is 68%. 68% is the turbine itself, the cost involved here. In between the 68% turbine cost, the rotor cost is 15%, the drivetrain cost is 37%, and the tower cost is 16%. The balance of the station is the 23%, and the soft cost is 9%. The balance of the station cost includes the foundation is 4%, turbine transportation 3%, roads and civil works 3%, assembly and installation 3%, electrical interface 8%, development 2%, and the project management is 1%. The soft cost includes the contingency cost is around 6%, and the construction finance cost is the 3%. So this is the total 100% cost. So major cost involved in the turbine design. Now come to the last point, that is the application of the wind energy. Primarily the wind energy is used for the power generation, and the wind energy plays an important role in majority of the applications such as the flour mill or the grinding mill, lift water to lighting purpose, pump water to the higher level, and to lift the load. This is the this figure shows the flour mill or the grinding mill. This is the lifting the load or the lift the water, and this is the lighting purposes. This is the windmill through grid and the control system, substations, transformer, the electricity generated. Come to the overall applications in the wind energy. Here this is the lighting, here this is the lifting the load, here this is used in the agriculture, the water pumping, here this is the cooling purposes, okay, or the grinding purposes, and the grinding mills are there. This is the energy stored devices, mainly for the agriculture crops production. And these are the main applications of the wind energy. And now I conclude, this is the overall discussions in the renewable wind energy sources. These are the references from which you can gain the knowledge. I built the tutorials of the wind energy sources by using these references, so you can go through it.